Hello, how to solve 3 to the power of k equals k to the power of 9. Solving for the value of k that satisfies this equation. Now, I can start by eliminating this k here because I want all the variables to be in one part and numbers in one part. So, to eliminate this k here, you can have 3 to the power of k, and this is raised to the power of 1 over k, and this equals k power 9, and this is raised to the power of 1 over k. Now, if you have a to the power of n, and this is raised to the power of n, which equals a power n times n. So applying this identity right here and here, I will have 3 to the power of k divided by k equals k power 9 divided by k. And k divided by k is 1, so I have 3 equals k to the power of 9 divided by k. Now, the next step will be to eliminate this 9 from here. So to achieve that, I multiply this exponent by 1 over 9. I have 3 power 1 over 9 equals k power 9 divided by k to the power of 1 over 9. Now, if I have a power n raised to the power of n, this equals a power n times n. So, applying that here and here, I will simply have 3 power 1 over 9 equals k power 9 times 1, that is 9 divided by k times 9, that's 9k. 9 eliminates 9. I have 3 power 1 over 9 equals k power 1 over k. Now, right now, we can observe something. The 3 here is different from the 9 here, while the k here is the same as the k here. So, to proceed with this solving, I want this and this to be the same. Now, what I can do will be, I can have 3 to the power of 1 times 1 over 9. And this equals k power 1 over k. Having this one here means something. I can easily replace 1 here with the equivalent of either 2 over 2, or 3 over 3, or 4 over 4. But I need the one that will make the base to be the same as this. So that is 3 over 3. So I'm going to have 3 to the power of, instead of writing 1, I have 3 divided by 3, which is the same thing as 1, times 1 over 9. And this equals k to the power of 1 over k. So let's start by multiplying the fraction here, the exponent. I have 3 to the power of 3 times 1, that is 3 divided by 3 times 9, that's 27, and this is k to the power of 1 over k. So observe something here. I can factor out this 3. I can do that. I can have 3 to the power of 3 times 1 over 27, and this is k to the power of 1 over k. So remember, if I have a power n times m, this is a power n or to the power of m. So I'm going to have 3 to the power of 3. This is raised to the power of 1 over 27, and this is k to the power of 1 over k. So 3 to the power of 3 is 27. That means I will have 27 to the power of 1 over 27. And this is k to the power of 1 over k. Have you seen that? So by doing the, or expressing this way, the 27 here is the 27 we have here, and the k here is the k we have here. So if you compare with this identity, a power 1 over a equals b power 1 over b, making 1 over a equals 1 over b, I can cross multiply. And by doing that, I have a equals b. So I can also have 1 over 27 equals 1 over k. If I cross multiply k times 1, I have k equals 27. So this is my value for k. Now, what I can do is to actually check if this value satisfies the equation, because it's very important. And next that we do it, k equals 27. So 3 to the power of k is k power 9. That means 3 to the power of 27 is 27 power 9. I have 3 to the power of 27 equals 27 is 3 to the power of 3. And this is to the power of 9. So remember, a power n to the power of n equals a power n times n. So I can have 3 to the power of 27 equals 23 to the power of 3 times 9. That is 27. So 3 power 27 equals 3 power 27. Have you seen that? So using this technique, we have been able to solve for the value of k, which is 27, and that has satisfied the equation. So that's it. Thank you and goodbye.